Assalamu alaikum wa rahmatullah. We are working on the first file of the 3 responsive questions for grade 11 elite. We are at question 6. We have the velocity of a particle that moves along the x-axis. The velocity v of t is given by cos of pi over 6t. Okay. We need to find when is the particle moving to the left on the given interval from 0 to 12. Well, first we need to find when is this particle is at rest to check the sign of the velocity. So if you set this equal to 0 and solve for t, you are getting 2 values for t on the given interval, 3 and 9. Now what happens at 3 and 9? The particle is not moving, the particle is at rest. Now let's check the sign of v of t. Now we know that our interval starts from 0 to 12, so this is what we are interested in. We have t equals 3, we have t equals 9, where the particle is not moving. But what's happening in between? Now if you choose test point between 0 and 3, like 1, the velocity will be positive. Choose 5, 4, 6, whatever between 3 and 9, the velocity is going to be negative. Between 9 and 12, it will be what? It will be positive. Now for the given interval, when is the particle moving to the left? Here. Because the velocity is negative, the particle is moving to the left. So it's moving to the left from 3 to 9. Find question number 7, find the acceleration of the particle at time t. So a of t will be v prime of t, and the derivative will be minus sine of pi over 6t times the derivative of the inner, which is pi over 6. So the acceleration at any time is given by minus pi over 6 sine of pi over 6 t, right? We need to find the acceleration at a equals 4. A of 4 is equal to negative pi over 6 sine of pi over 6 times 4, which will be, this is question 7, negative 0.453. So the acceleration is negative, and v of 4, if you look at the number line, v of 4 is here, 4 is here, so v of 4 is also what? Negative. And because both have the same sign, same sign, what do we say? We say that the particle's speed is decreasing. The particle speed is decreasing because they have the same sign. Sorry, it's increasing. Speeding up, it's increasing. I'll take it back. Increasing. Okay, moving on to question number 8. Question number 8 says the velocity of a particle moving along the x-axis modeled by a differentiable function v, where the position x is measured in meters and t is measured in seconds. Selected values of v of t are given in the table. The particle is at position 7 meters when t is equal to 0. For the interval from 0 to 40, must the particle change direction at any of the sub-intervals indicated by the data in the table? Well, the key phrase here is what? Change direction. Change direction, that means the velocity v of t changes what? It changes sign. Okay, when is this happening? It's happening here and here, right? Here the velocity is 5, it's positive 5, and then minus 10. On the other one, it's negative to positive. So, what do we say? We will say yes, right? We will say yes. And this is happening on which interval? On this interval, 8 to 20 at some point, and 32 to what? To 40, right? Because V of 8 is positive and V of 20 is what? V of 20 is negative, less than 0. And on the second one, V of 32 is negative, يعني less than 0, and V of 40 is positive. That's question number 8. Question number 9 says a car is traveling on a straight road. The given interval is from 0 to 24. The car's velocity, okay, the car's velocity is modeled by the piecewise linear function defined by the graph above. Let A of t be the car's acceleration at t equals a time t in meters per second per second. Write a piecewise defined function for A of t. Well, there are 3 pieces because there are 3 line segments in the given interval. Now, we know that the acceleration A of t is v prime of t. That means it is the derivative, yani the slope of the tangent line. Well, what is the slope of this line here? Okay, dv over dt. Well, you have to find the slope between these 2 points, right? So for the first interval, A of t will be 3 pieces. This one, f t is between what? 0 and 4. We have another interval runs from 4 to 16, sorry. 4 to 16. And the last one runs from 16 to 24. Okay, for the first one, it will be the slope. It will be what? y2 minus y1 over x2 minus x1 between the given 2 points. So this is going to be what? 20 minus 0 over 4 minus 0, which is 5. So here, this is 5. Well, the second one, it's a horizontal segment. That means the velocity is constant. If the velocity is constant, the acceleration will be 0. The derivative of a constant a constant velocity is 0. Or this is a horizontal line segment. Its tangent line or its slope equals to 0. Okay, and for the last one, it will be again dv over dt, but now between this point and this point, which will be what? 0 minus 20, 0 minus 20 over 24 minus 16, which is minus 5 over 2, minus 5 over 2. So this is the acceleration function. But notice that there are 2 sharp points, right? There are 2 sharp points. The first one is here, and the second one is here. So what do we say? We must indicate that A of t does not exist at t equals the first one 4 and at t equals 16, because it's a sharp corner, sharp point. This is question number 9. Moving on to question number 10. Let me just... Well, a particle moves along the x-axis, so its velocity at any time is given by v of t. Find all values of t for which the particle is at rest. At rest, it means that v of t equals to 0. So if you set this amount equals to 0, okay, on the given interval, which is from 0 to 2, and you solve this one, you are going to get two values for t. T equals 1 over 4 and 5 over 4. This is what happens in the first question.